All right, so Spelunking the Bitcoin blockchain is what I call this one. And I work at a company called Elastic. This is our logo on my shirt here. And we make something called Elasticsearch. And I've been there like 2 years, and Elasticsearch lets you do these crazy things with data, right? And one day I was talking to a friend, and he pointed out this project someone was doing to take all the Bitcoin data and put it in Elasticsearch. And I thought, that sounds really cool, right? Like, what can we find in that? And this has been about probably a year and a half of effort at this point. It's something I do on and off. It's a bit of a side hobby. And I found ridiculous things in this data, and it's so much fun. And every time I sit down, I know an hour of my life is gone, just because of, it's like going down a rabbit hole. And I'll show you guys in a little bit. But so the graph there is the Bitcoin price. For those of you who can't see in the back, I'll do my best to point out what the numbers are in the graphs, because I know they're very small for those of you way in the back. And even for me up here, it's not a big screen, so I can't really see them either. But basically that's showing the meteoric rise of Bitcoin to, what, 20,000 US dollars, and then something happened to it. And actually we can show, I've got some data that helps show like what happened as part of this. And I can't necessarily explain why it happened, but I can show you some of the results, which is pretty awesome. So anyway, let's get going. There's going to be a lot of clicking, things seem disorganized, because this tool I'm using is called Kibana. It's not meant for presentations, but I'm using it for one. So those of you who work with Kibana, you know it's probably not the most friendly. So anyway, as of right now, this is current data. There are 571,262 blocks in the Bitcoin blockchain, and the data on the bottom is the time of the last block. What is all right, let me get rid of that. This is part of the fun of live demos also. So anyway, what are we, April 11, 1948 is, what is that? Math is hard. That's 7:48 p.m. is when the last block we're looking at right now came in. And this will update itself as we go. About every 10 minutes, a new block gets generated. So if we go back to this number in a few minutes, it won't be that. It should increment by 1. It doesn't always. It's complicated. We'll get to some of that stuff. But anyway, it's all live. This is just my example showing you what's going on. And we'll keep going. All right. So, like I said, a block is supposed to be generated about every 10 minutes, and this is basically the graph of Bitcoin blocks being generated over time. You can see at the beginning, it was a little weighty and shaky because it's Bitcoin, right? This is just a crazy time, Wild West. And it's leveled off a little bit. And if we look here, this is about 5,000 right here on this line that you see. So slightly less than 5,000, we're like 446, we got 4438. Anyway, that's how many blocks are being generated every 30 days, right? So we can see there's a certain amount of consistency. There's a dip over here, and we'll see what that's from later. So keep going. Now, inside of every block is also something called a transaction, right? Well, or one or more. A block has to have at least one transaction. A block can have a lot of transactions. One block in particular had, I'll tell you the number, it had 12,239 transactions, and it's an anomaly. Excuse me. But if we look at the entire blockchain since the beginning of time, which is slightly before after January 1st, 2009, we have 400 million transactions. And so this is the data we're working with. Like, this is, everything we see is happening before you, right? 400 million is a lot. Well, it's not. We think it's a lot. It's a lot to me, it's a lot to you. Visa does that in a day. And this is what Bitcoin has done forever. So, I mean, just think about that for a minute. And here, I'll show you what the data looks like, because that's fun. So I've broken the data up into a couple different pieces. There's a block index. I've got the transaction index. The transaction index is the one that has 400 million documents in it. So that's the big one. I don't like to click on that one because it makes things go really slow for a few minutes. Usually less than 1 minute, but when you're the guy on stage giving a talk, 1 minute is a really long time for nothing to happen. And so I'm going to do my best not to do that. I've got some backup jokes and stories if it needs to happen, but we don't want to do it, all right? So anyway, we've got our blocks, we can look at that, and here's just our block data here. And this is what a Bitcoin block looks like, right? We've got, excuse me, most of this doesn't matter, and you guys probably can't read it anyway, so I will point to what I can. We've got something called the difficulty. That's something to pay attention to for later. There's the hash, and the hash is related to the difficulty, and it's how a miner generates a block. There's a height, that's just the block number literally, and obviously 571, 261 is what we're looking at here. Most of this other stuff we don't care about. The nonce will be interesting because the nonce is what's used when you mine a block. So what happens is, excuse me, there's all these miners out there, right? And we always think of Bitcoin as magic money in the sky. And these people have all this gear, doing all this work, mining all this stuff. And essentially what happens is they take all this data, they stick it into what they want to be their block they are mining, and they get to change one bit of data, and that is the nonce. The nonce changes. They change it until a nonce gives them a hash, which is this one up here. A nonce gives them a hash that is equivalent to the difficulty they are looking for. And that sounds really complicated and weird, and I will show you pictures of how this all works in a little while, so don't worry about it. And then we have the size. Every block has a size. Bitcoin has a maximum size for a block. It's 1 megabyte. This one is 1.2 megabytes. And we'll talk about that too. And there's something called strip size, which is less exciting than anything. But that one is less than 1 megabyte, and that's because Bitcoin did something clever to get around the maximum size of a block. It feels like politicians sometimes where they're saying, yes, a Bitcoin block is less than 1 megabyte, but it's not, right? Excuse me. We've got a date obviously associated with everything. All of Bitcoin has a lot of dates in it, which when you're working with this data makes it much, much easier to deal with because anytime you have a date, you can start graphing things in a reasonable manner. And then we don't care about the rest of this stuff, so that's fine. So let me go up here and I'm going to change my date. This is up here, I can adjust the date to be anything I want. I'm going to set it to 1 hour and then I'm going to select the transactions. And you're going to see even this is going to take a second or two. And that's 17,413 transactions in the last hour. So it's a lot of data. But these are where all the fun stuff actually comes from. And this is where, excuse me, this is where the data we're going to look at later, like the secrets and the fun things hidden in the Bitcoin ledger exist. This is going to pop. All right, so anyway, we've got essentially our transaction. I should also clarify one thing. So when you run Bitcoin, you have the Bitcoin client that attaches to the Bitcoin network, right? And all I'm doing here is the Bitcoin client has a very nice JSON RPC interface. And all I'm doing is taking the data it gives me and throwing it into Elasticsearch. The Elasticsearch also likes JSON, which made my life much, much easier. I take a little bit of stuff out because my initial data set was 3 terabytes of data. That's a lot. And it's surprisingly difficult to host that much data in a way that doesn't get you yelled at by your company. So I stripped it down, and now I'm dealing with, I think, 300 gigs-ish, maybe a little more. It's much, much more reasonable these days. And the way I did that is, if you look down here, there's, well, I'll clarify. So we got our transactions. We got every transaction has a size. Most of this other stuff we don't care about right now. There's the height associated with it. But then we have these parts of the transaction called kind of the V in and the V out is what they call it in the Bitcoin universe. And essentially V in is where things are coming from, V out is where they're going. And so you kind of take all this, and Bitcoin has, it's like a little virtual machine almost inside of it, where you kind of write code that says this is what you need to do with all this magic money in the blockchain. And it's hard math and it's stuff that I'm not gonna lie, I don't totally understand. But anyway, in here, in this V out, there would be essentially a little script. And I took them all out because I don't need them in this data because they're basically random nonsense. And storing it in any way was just taking up tons and tons of space, and I didn't care. And it saved me a lot of room. So anyway, that's what we're looking at. And you're gonna see the V-ins and V-outs are all different sizes. And right before this, there was a different talk on Bitcoin, and that was clarified much better. So go back to that talk if you want to learn how this all works. It'll be on YouTube. And there's way smarter people than me that can explain this to you. But it doesn't matter. So we're going to keep moving. This one. All right. So now I'm going to fix this. See, I've got to put it back to where I have all the data. This is the difficulty. Now this is where it starts getting fun, and this is where I started learning a lot about what's going on in Bitcoin. So the way it works is we talked about that hash, and the difficulty dictates that the hash you have to generate as a miner is dictated by the value of the difficulty, right? And you can see difficulty goes up, it's harder to do. And the Bitcoin network deals with this by saying every now and then it says how long has it taken to generate the blocks, and if it takes too long, it lowers the difficulty, and if they're generating blocks too quickly, they raise the difficulty, because the intention is one block every 10 minutes. So over here is the difficulty graph just shown in a very linear way. Obviously, that's a crazy looking difficulty graph right there, and this is why when you hear people talk about Bitcoin using the same amount of electricity as a small country, this is why. And it's been going up like crazy. Does anyone want to guess what happened when it suddenly took an enormous dive? If we overlay the price on this, and we'll do that later, when the price sinks, this is exactly what happened, is miners obviously left. And that's what that means. It means fewer people were mining Bitcoin than were doing it before. And the price is going up again, and so you can see the mining is going up. Now, the one thing to keep in mind though, is the other side here, this is the logarithmic graph of mining. So even though it looks like an insane dip there, it's really not that bad when you kind of look at it from the data sciencey way. And now here's one of the really cool things. If we take almost any section of time in difficulty, it's always going up like this. It doesn't matter what part of that graph I select, this is the graph. The Bitcoin difficulty has always been going up in this manner. And it's just, I guess, the nature of Bitcoin, because it's been gaining in popularity, and so it keeps getting more and more difficult, faster and faster. And this is, it stopped, but it's one of the many reasons you hear complaints about Bitcoin and the power it's using and why people consider it so wasteful. All right. Now I also talked about the size a little while ago. A Bitcoin block can be 1 megabyte in size, except it's not. And so what happened was, you can see there's a plateau there, where for a long time, the Bitcoin blocks were basically, the miners were making them as big as they possibly could, right? But they hit a wall, and obviously they wanted to stuff more transactions into a block. And so the solution Bitcoin did was this thing they called segregated witness. I'm not going to go into many details, but it essentially moves some of the data into like a meta area of a block. So now the blocks can technically be larger, which we see here. And in fact, we've got blocks that are going, what's this peak here? It's 2.3 megabytes, right? So we're 2.3 times the initial size that the Bitcoin people were looking for. And you'll see back at the beginning, the block sizes were much, much smaller. And that's obviously just due to the fact that the network was doing much less work than it's doing now. And so this is important also, and I'm going to show you this when we start comparing some of this data, because that's where it gets really fun. All right. So now, the reason they increased the size of the blocks was obviously they wanted to fit more transactions in, right? Except the red line represents the number of the average number of transactions on the network, kind of per block, right, over time. The green graph is what we were just looking at. And you can see that transactions really haven't changed very much from where they were. So anyone who said they needed larger blocks for more transactions, yeah, that was a lie, obviously. The peak we see is actually the price. And we'll show that. We'll show price and transactions here in a minute. But this is one of those things that I always love, where you always hear people say, oh, we have to do this thing because, and then they do it, and it obviously doesn't make a difference. And I have a suspicion the bigger thing holding transactions back with Bitcoin is just the fact that it is expensive, and the network is kind of unreliable and weird. So what happens when you put a transaction in the Bitcoin network, I'll give you some of the background here. There's a concept called the mempool, where it's like this magic ephemeral space that's kind of part of the Bitcoin network. And what happens is, like, let's say I have a transaction where I want to pay someone to Bitcoin. I put the transaction together, I submit it into the mempool, and then it sits there till a miner decides, I want this transaction, and I'm going to include it in the block I mine. And you include a transaction fee as part of that. And there's some funny transaction fees we can look at in a bit too. But, so basically what happens then is miners decide how much crap they're going to put into a block, and then they're going to do it. And so one of the challenges, though, is they have to make sure the things they're putting in the block are actually valid. And so there's a certain amount of time that has to happen, or rather, they have a finite amount of time to actually assemble the block they want to mine and then start mining them. And if they're too slow, the next block gets mined and they have to start all this work over again. And so this is something really important they have to pay attention to. So if they put too much stuff in a block, they're going to lose, and they're going to have to start again. And so I have a suspicion that's what's holding a lot of this back more so than anything else in terms of the technology these people are doing. Now another interesting thing, and we can pull up a graph of this later, is if you graph the minimum size or the minimum number of transactions in blocks over any period of time, it is consistently 1. Which means there are still people who are mining blocks that have nothing in them only to get the reward. And the reason for this, I found out, I actually did some research because I was like, why is this happening? This doesn't make any sense. And it turns out that what happens is a new block gets cut, and then the miners just start mining empty blocks because they're saying, before we put together what we're going to do next, let's just start mining nothing. And some of them get lucky and they hit an empty block. And so you don't get all the rewards from transferring all the other coins in these transactions. Because every single transaction comes with some sort of kind of payment as the thank you for processing my transaction. And there are some that are 0, and there's some that are ridiculously large, which is its own strange story. All right. Now, if we're looking at transactions, this graph makes way more sense. The red line is the average number of transactions, and the black line is the price. To give you an idea, we've got a peak. The transactions like 22.53, give or take. Max price is about 20,000. So it would seem that the price of Bitcoin is, the number of transactions in Bitcoin is more dictated by price than anything else. And I think one of the really interesting things here is obviously the number of transactions tanks after Bitcoin has its rough patch here. But then I have a suspicion the number of transactions going back up would signify some level of selling off of the currency. Which I'm not an economist, I'm not a data scientist. If any of you are, by all means, feel free to interrupt and tell me I'm an idiot. Or if you have questions, we can dig into this as well as we're looking. Again, it's all live, it's fun to do. In fact, here, I'll grab it and we can take a peek here. Where it looks a little silly, it's obviously very up and down, but the price has been, the price is captured per day. My transactions are captured obviously every 10 minutes, so that's why the graphs kind of look like that. But you can see it's not pretty. And anyone who's invested in Bitcoin, I'm sorry. All right, let's see. I gotta fix my date. And then I also enjoy this graph, which is where we compare the transactions to the difficulty graph. Again, red line is transactions, the green is the difficulty. And it looks a little different on here just because of the way I've got my data set to put it together. So anyway, you can obviously, as difficulty goes up, transactions go down a little bit, and it's just, I don't know. This one amuses me. I don't know what to make of it. I feel like there's something here, but I'm, again, not a data scientist. I don't know. All right. And, not that one. All right, cool. So now I will show you this graph, and this is where I just kind of put a lot of this stuff together and give you an idea of what we're looking at, all right? So we've got the very first block, the Genesis block. If you can see it, that's January 3rd, 2009. The current one, we're now at April 11th at 8:11. Oh, so that just came in. Very exciting. So that's what we got there for the latest. There's now 571, 264. There was what, 262 I think when we started, was it? Right. So yeah, the data gets updated. It's actually, there's a machine in my basement in Green Bay actually that's doing most of the work here. And then the server running Kibana and Elasticsearch is in the cloud, which I don't know where that is, but it's somewhere. And then I also have this on here. It shows minimum height, 0, obviously when it begins. Maximum height, I show that because when I'm selecting different pieces of data and I'm analyzing it, this is an easy way to just jump in and say, all right, what does my date range look like? What are the values I'm looking at? What's going on here? And then obviously the blocks graph and the transaction graph as well. And this is just kind of my debugging, I guess, screen I use, and the difficulty we've seen in the conference. All right. Now, I've got one other fun thing to talk about before we move on to where the whole talk will just go off the rails for the most part. So, 401 million transactions. We've got our transaction graph there. But down here is, you can't read any of this, I'm sure. I can barely read this on my screen. But these are called the transaction types, okay? So a Bitcoin transaction isn't just moving money around. This is something I learned when I started this. I did not know this. So there's something, the first one, the big one, is called a pub key hash. That is what we think of when we think of Bitcoin. That is where you're moving money, essentially. Where you're saying, I'm taking some of my Bitcoin, I'm paying you some of your Bitcoin. Again, the talk before mine, phenomenal talking about this. You should go see it. And then there's something next called script hash. Now a script hash is the ability to kind of write like a little script that says when certain conditions are met, I want you to basically move some money around. And this is, it's a little more complicated, it's not too bad, look it up. I'm not going to go into it in this talk because it gets really weird really fast, and it's something that just hasn't concerned me a lot. And unfortunately, you don't know what the scripts are necessarily because it operates on the hash of the script. So it makes it even more weird and hard to deal with. Like it can literally be anything. The next one is something called null data. Null data is what we're going to look at in a minute. Null data can be anything. You can put anything in the blockchain. It doesn't have to be rules to move money around. There's a cake recipe in the blockchain. I'm going to show it to you shortly. Yes, for real. There's a Rickroll in the blockchain. I will show it to you. People have put data. I've only found one image so far in all the work I've done, and I will show you it. There's supposedly more. There's URLs in there. There's these off-chain ledgers people use, where basically there's like these organizations that kind of built their own blockchain for something, and they every now and then will kind of put like a checkpoint into the Bitcoin blockchain. Is one of the things they do. It's just it's awesome, right? That's all I'm going to say. This is like being a little kid and finding a secret place, right? Except it's all in public. And also, we're going to search it. If you're easily offended, you should leave. And then we're going to ignore the rest of these because they're much less exciting. And there's very few of them. All right, one more, and then we'll get on to the fun stuff. The other one I like to look at is this one's going to take a while. All right. So one of the fun things I look at is every single transaction comes with an address, right? There's either an address sending money in, or there's an address that the money's going out to. And so what I did is I looked at the top 10 miners, which this is actually kind of horrifying when it comes up. And then there's just the top 10 addresses, like what are the most active addresses in Bitcoin? And some of these I can't figure out. But we're going to see the miners. I've looked at the miners, they're all pools. And so what happens here as well, and this is not well known, there is a concept called pool mining in Bitcoin, where instead of being one miner trying to figure out what the magic is to get the Bitcoin to work, everyone pools their resources together. And so now, instead of, say, be able to do a million hashes a second, you can do trillions. Or heck, at this point, they're probably into, what, petahashes? I don't even know. I used to mine Bitcoin back when, like, if you had a couple thousand hashes a second, you were awesome. But now it's I can't even imagine. But anyway, here's what's crazy. So there have been, what do we say, 572,000, I forget. How many blocks were 500 and change, right? 500,000 and change. One address has mined 45,000 of those blocks. This is a pool. I can't remember the name of it off the top of my head. I knew that. I looked it up, and I thought, I should write that down. Oh, no, I'll remember it tomorrow. Nope, sure didn't. But anyway, and you can see, like, it's very long tail when we look at the miners. This is one that did most of the work. And it's your typical just distribution when you're looking at sort of any sort of data set. You see this all the time. And similar thing, now the addresses are a little harder because you don't necessarily know what the addresses are. I couldn't actually find anything exciting on this first address here. But it's, yeah, I don't know. It's just a fun thing to look at, fun thing to think about. And you gotta think, there's basically one address has mined what? Almost 10% of all the coin we've seen in Bitcoin, which is, that's crazy, right? And every time they do it, I didn't save the dashboard because it was really, really slow to load. Excuse me. But they've mined, this one address has mined like 600 and some thousand Bitcoins that they've collected so far, right? Like that's a lot of money, right? You figure that times 5,000 is what they have right now. Although I should say too, it gets split up. So when you're part of a mining pool, like you get your cut. Okay. All right. So now we're going to look at the fun stuff. So I've got here an index I called BTC operaturn file. So what I did is I wrote a script that went through all the transactions and it looked for that null data, all those null data transactions. I knew anything that was null data was not a regular transaction, so that's something fun I want to look at. And actually, this started, and the Bitcoin devs realized it was a problem, because at first people were just putting trash into the block, into their transactions, and it was messing up the clients, because the clients were trying to do work, and sometimes they were crashing, and it didn't make sense. And so what they actually did is they created a special opcode called operaturn. And they asked you, when you're putting garbage into the blockchain, please put this operaturn as your first little instruction. That way it just tells the client, give up, don't even look at the rest of this stuff, because it's garbage. And actually, there's a graph I can show you later, where if we look at the value of all the transactions, there are some transactions that the client thinks are larger than the total number of Bitcoins in existence today. And the reason that is because people put garbage into the blocks and the client doesn't know what to do with it. I can pull them out and obviously ignore that data when we're looking at it, but I mean, this is one of the things that the developers had to worry about, and they kind of dealt with. And for the most part, most people play nice. So anyway, what I've done now is I took all this data, right, and I've got to paste them together too, because one of the other things the developers did, these sneaky jerks, they limited it so you can only do, I think it's 40 bytes now of null data inside of your transaction, which is unfortunate. So what people do is they split apart their transactions and you have to kind of chain them together. And so what I had to do was reverse engineer their chains. And I know my logic is flawed, I know it doesn't work correctly, and sometimes it does the right thing, sometimes it doesn't. This is just kind of part of my ongoing project, is understanding how I can figure this out better. If anyone knows, please tell me, patch it over. And so anyway, I've got to take all this stuff, I need to paste it together and try to reconstruct coherent data. And then, for some reason, some people they put base 64 encoded data inside of these transactions. And I'm like, WTF guys, it's already, so they base 64 encoded their stuff, then they split it apart, and then the Bitcoin client rebase 64 encoded the data again, and then they stuck it in their transaction. And it's like, this is dumb and you annoy me, I don't like it. But anyway, so what I've done here, we've got, basically I record the block, because at first I wasn't recording the block, and it's fun to know where this stuff comes from, right? So we can look up the block, we can figure out what's going on with this. Data is the data in the file. This one is empty, it has a size of 0. I don't know why, but some people have operaturn transactions with nothing in them. I have no idea why they're doing that. They're paying money to do nothing. And I don't know if it's a mistake or if there's just some madness going on I'm unaware of. Nothing makes sense in here, right? That's about all I'll say. So anyway, let's find one that has real data that's slightly more interesting. There's a whole bunch of zeros. These are all zeros. All right, I give up. So anyway, and then I got the data. Let's just do some searches. So here, for example, if I search for cake, I don't know, let me... Cake. Yes. Okay, there we go. Can you guys read that? It's a little bigger. All right, right. So up here, it says the cake is a lie. Is a first. There's only 2. Of all these, I will not search for naughty words, but most of them appear less frequently than you would think, is what I'll tell you. You can do this on your own time. I'm not getting recorded with that. Right? They're recording me, so I have to behave to a certain extent. But here, the next one here, this one is cool. And this one actually, I'll tell you the story. This is, it says, "Happy birthday, Martin. Please find your delicious birthday cake attached." And it says it's Python code. From measurements, import teaspoon or tablespoon, teaspoon, cup, ounce, blah, blah, blah. And then it has a cake recipe. I've not made this. I keep meaning to. It's probably not good if I do this. But yeah, somebody put this into the blockchain. And they did it on, what block is it on? 430, 447. So that's fairly recent, right? That's not super old. So somebody probably paid a non-trivial amount of money to do this. And the reason I found this, and this is the story I love to tell, that makes it so much fun. I was not looking for cake recipes when I came across this. I was looking for Python code. And because they happened to make it Python code, I happened to find a cake recipe. And it's like, what the heck is this, right? And actually, I closed my computer after this at night. He said, that's enough internet for a while. But then here's the thing. This is the fun, right? We can dig in, we can look for amazing things that don't make sense, and some of it is madness. Here's another one. I'll type gonna, and we can see there are 6 hits where people put essentially Rickroll something or other in the blockchain, right? Like, and this one here is pretty good. Like they got a lot of the song here, like they added. I mean, again, someone paid to do this. This one's early though, block 266. So they probably only paid a couple of cents. But yeah, basically, most of the song of Rick Astley is now in the blockchain as text. So, go figure. And before I forget, I will show you the one image I found. I actually have all these files also on this computer. There's 2.some million of them. But can you see this? This is it. Look, that is the only actual graphic image I have found in the data so far. No idea. Right, everyone's shaking their heads. Yeah, right. Again, that was another one of those, that's enough internet for now. Although, the one thing I will say is I've heard reports of obviously pretty dodgy stuff in here, like we'll say potentially illegal images and whatnot. And like, when I saw this one pop up, I thought, oh man, I hope it's nothing bad because I don't want to have to tell people I found an image, but I can't show you because it's illegal. So I'm actually glad it's super benign and pointless in that regard. And actually, if we come back here, we can do a search, and there's a number of references to The Economist in this data. And I spelled Economist wrong, did I? No. It's coming up 0. I don't know why. I promise I found them once. I'm doing something wrong. Anyway, all right, so here's where it gets crazy. What do we want to look for, guys? Don't be shy. Oh,
Coinbase.
Come on. What?
Coinbase.
Coinbase, there you go, yeah. I did this actually, and it was 6. Oh, right, that's going to be a problem actually. So Coinbase did Coinbase job application. Did one of your people put a job application on the blockchain? Yeah, that's fantastic, right? Why not? That wasn't you.
No.
Okay. Here's Coinbase job application. Ooh, Coinbase referral, $75. Look at that. My friends, right? That's still valid, or are you guys done with that? No idea. All right. What is that one? 370. So that's been a while. What is here? Alipay or Coinbase. There's also a surprising number of BitTorrent hashes in here, where people have stuck in just random data about something. I haven't downloaded any of those. There's also a lot of URLs, like URL shorteners and stuff, and I don't know what to do with those yet. And that's something I've been thinking about a lot, because it would not shock me if visiting some of those will get a visit from somebody if I did it, and I don't want a visit from somebody. And so I've been pondering, I don't know, maybe doing something with Tor and writing a script to do some scraping or something like that, just so I can potentially protect myself to a degree. But again, that also brings up the issue, like what happens when I find something insanely illegal, and what do I do with it? And like, I don't know, luckily, I've not found anything horrible yet. And that pleases me, because this is a hobby, right? Like, I don't need to go to jail for a hobby. That would be upsetting. My wife would probably get really mad. All right, so what else we got? Someone's got to have something.
Classified.
Classified? Sure. And this is part of the fun too. Nothing. That's a shame. That seems like it should have something pop up, right?
Does your search just do literals, or does it do regexes as well?
It doesn't do regexes exactly. It's Elasticsearch, so we can do certain kinds of queries, but it's less easy than I would like, I guess I would say. And if we send it a regular expression, they're very slow. Elasticsearch is not built into regular expressions.
Right. I was just wondering if you found things like IP addresses or MAC addresses in there.
There are. They've come up, and that would be a great. Actually, so what I can do is next time I go to import the data, I can basically tell it, while you're importing the data, look for IP addresses and flag them as such. And that would be the right way to do it. But no, that's a good call, because there's definitely IP addresses. There's URLs. Here, I'll show you guys one. Like if I type in HTTP, spelled right, we're going to get 5,173 hits.
What about FTP?
I don't know. I don't know if I've ever searched for FTP. 22. And not all are FTP though either, because obviously there is, in fact, none of them might be FTP.
I don't think they're actual FTP.
Let me put in ://0, which, I mean, good job guys, right? We're using FTP. But like this is, so anyway, back to the HTTP, right? 5,000 hits, that's part of my challenge here. I can't look at 5,000 files. And in fact, when I started this project, I'll never forget, is I started exporting these files, and I had about 10,000 in the directory, and I thought, oh, I'm going to just start, like, I wrote a little program to just kind of page them, you know, basically 1 page a second. And after about an hour, I realized this is unsustainable. Like, humans cannot do this work. It's too boring. It doesn't look like anything. And, I mean, you've seen the data. A lot of it's garbage. And I know some of that garbage still has gold in it. I just haven't made it around to figuring out what all of it is yet. And that's, I mean, that's part of the challenge. Like, this isn't my job, unfortunately. So if someone would like to hire me just to do this, I would totally do.
Yeah,
But
it sounds like a lot of it is steganography. Like, it might seem innocuous, but it's like a plan for someone who knows what to look for.
right, and, yeah, right. So this gentleman just said he thinks some of it could be stenography, essentially, where, you know, hidden messages for somebody knowing what to look for, and I have no doubt. And in fact, we can look here. There's some PGP data in here, right? 3,000 hits, where some of it is just that the letters PGP come up. But like here, there's a PGP signed message, right? I unfortunately can't, well, I haven't tried to see. I know there's, what was it? There was a Usenet group where people would just post like random PGP crap to it with the intent to be a message for somebody who knew where to look for it. And some years back, someone actually did some analysis of it, and a surprising number of the passwords were really, really bad. And so they were able to break some of it. And so it wouldn't shock me if some of it's that. But yeah, like, there's the weirdest stuff in here. And what do you do with it? I have no idea. I wish I did. But again, weekend project, fun to do. It's something that keeps me busy. So, and here, I'll show you guys one other really cool thing. Yeah, I've got some visualizations here. Let's see, here's this one I like. So, remember I mentioned there's the nonce, which is the thing the miners can change to find the hash they need. The same nonce has been used 3 times on the blockchain, which I don't think that means anything, but it amuses me to learn it, right? Like, that's something you just can't find out normally. And of course, part of me thinks so too. I would love to like put that out on Twitter or something and just see what happens. Because you know there's probably some silly miners that'd be like, oh, I'm going to use these 3 nonces now over and over again every time. And that obviously doesn't matter. This is playing the lottery and winning is all it is. And then I also have, next page, I have some tag clouds that are fun to look at. So one of the cool things we can do here is build a tag cloud of all the terms that I've collected in that text. This is a boring tag cloud. Now Omni shows up a lot, like a lot. In fact, here, let's pull it up. I'll tell you how much it shows up. Another one of these pauses. Did you guys hear the one about the joke in UDP? I don't think you get it.
Oh.
Yeah. So anyway, Omni, the term Omni is in 1 million, well, it shows up 1 million times, right? It's not in 1 million documents necessarily, but those are the hits. No, that is, that's where the hits were. So Omni is one of those off-ledger chains, and they have a lot of check-ins into the blockchain. And when we look at them here, there's what I did is my script takes out anything not ASCII. And so every time we see the word Omni up there in every yellow highlight, there's also like binary data after it. But I stripped it out because I can't show it, and Elasticsearch doesn't like it. So anyway, all right, so that tag cloud sucks. But I have a tag cloud that doesn't suck. And I will show that one too, where I took out all the crap. All right, so here we filtered it. And you can see, this is all the stuff I take out, all this red stuff, where I take out like all the letters of the alphabet, all the numbers, like CC shows up a lot, I don't know why. But we take that out, and now we start getting a little more interesting. There's a scribe tool thing, is another off-chain, and unfortunately that's getting in the way, so let's get rid of it. And this is part of the fun, again, like something happens, you get rid of it, and now it's gone. So now we can see, obviously, you see like HTTPS, there's lots of messages in there that talk about unsuccessful double spend attempts. And you can see it says here, unsuccessful double attempt. So we go and there's spend. And like, I don't know why that's in there either. I don't know if that's some weird off-chain message, something. I have no idea. It's very weird, but it's fun. Excuse me. Now, the one thing that does please me, as a security person at a hacker conference, HTTPS made the list and HTTP didn't. So good job, Bitcoin weirdos, right? You got that one right. But yeah, again, it's one of those things, and we can come in here and like I think, what am I showing for my tags? 25. So let's bump that up a little bit. And we'll see if there's anything more exciting if we do 50. And again, this is the way it has to be, right? When you're looking at data like this, if you can't get your results instantly, it's not exciting. And that's part of the fun here. All right, what do we have here? Anything cool? I have no idea. Can you guys even read that? I'm sorry.
Yeah.
I'll point out, so there's the and EW. EW is another one of those two letters that appears a lot. I don't know why. It doesn't make sense to me. Not an expert, but we've got what? Blockchain, spend, attempt, hello. Hello is a fun one, actually. Let's do hello. I like this one. Because there are a ridiculous number of people who just put like hello somebody or hello Bitcoin or hello Satoshi in this. And let's see. All right, 1 million. What the hell? No, I can't. All right. So what actually happened there was Kibana was loading the previous request I sent it, and it finished and it showed it to me even though I sent another one. It's getting fixed in one of the next versions. Anyway, what do you have? 343, like hello blockchain. And just, yeah, people put the weirdest stuff in here. Oh, I know one other one that's fun. Satoshi's a good one to look up as well. So, for those of you who don't know, Satoshi is the mythical creator of Bitcoin. Nobody knows who Satoshi is. There's some predictions in here, actually. Let's see, where is this? It wasn't here at the top last time I searched. Unfortunately, how many of them are there? There's 78. All right, we just did 3 here. All right, hello Satoshi, thank you Satoshi Trader. All right, where is it? Oh, there was somewhere in here where someone was claiming who Satoshi was. Good luck. Ah, man. All right, I'm not going to bore you guys digging through all this. But anyway. Oh, wait, there was Satoshi.
Good, right?
Satoshi was here.
I'm the real Satoshi.
I am the real Satoshi, yes. Justin, Andrew, Kevin, I don't know who that is. Dude, like, you're in the Bitcoin universe. Does that make sense to you?
It's the bit refill guy.
Is it?
Yeah.
Oh, okay. Yeah, that's awesome. And when is that one from? That block is, let's see here, 409995. So that wasn't that long ago. That would have been, what, maybe a year or take. So anyway, all right, we're nearly out of time. Is there anything else? You guys have any questions you want to search for quick? Again, this is, I'll tweet this out with the @CypherCon mention, the link to my GitHub. Yeah, for real, like, grab this, mess with it. You know, like I said, patch is welcome. I'm not an expert in any of this, and I'm sure if any of you are smart, you're going to look at it and be like, this guy's an idiot, and you're almost certainly correct. So just take pity on me and send me patches.
So, into the nature of a landscape, there's no way we can search for, like, ASCII art.
That is correct. He asked
Yeah.
if, just given the nature of Elasticsearch, could you search for like ASCII art? And I cannot, but that would be, I need to think about that, because that could be really cool actually. What I could do is look for strings with carriage returns specifically in a block. That could be cool, because it would not surprise me at all if there's ASCII art in here. And actually, I had not thought of that before, so thank you. You've given me something to do. All right, anyone else? Yes?
You ever look for non-image files?
Yes. There are, actually here, I have a visualization I can show you quick that shows the file types. And one of the things I did is I don't know, is it thinking? It's broken. There we go. So data is the biggest one. What I do is I have all the files in a directory structure, and I just run the new file command over them. And data comes up a lot. So obviously some of this data isn't data, and I need to figure out something to do with it. But like if we filter the data out, we get a better idea. Empty also comes up a lot. I don't know how many empty files are there. But again, so we've got a lot of Unicode, ASCII. There's COM executables for DOS show up a lot. I tried running a couple in the VM running DOS. None of them run, so they're not actually COM files. They're just garbage that the file command thinks are COM files. PGP secret keys show up a lot. And again, I've tried importing a bunch of them, but we've got, how many are here? There's about 1,610. I just need to like write a script. You like tear through them and just try importing them all, see if any of them work. But I haven't made it that far to do any stuff like that. But essentially there's I forget the number, I think there was something like 1,000 different file types that have appeared, and so far, all the image files specifically I've looked at, and there have been, it claims there's MP4s, but like a 26 byte MP4, but no, I haven't found anything else I can open with anything yet, but I'm hopeful they're there. And the sizes range obviously from 0 up to, there's a couple megabytes, so it depends. And again, this is one of those things, like I know all those data files, they're not all data, right? All right, one more question. Someone over here had their hand raised, I think.
I saw when you had that word, well, the image of all the words up, I saw
Yep.
one of them was KMD. I'm wondering if you found out what that was. I have a theory. I believe Komodo is another blockchain, and they have delegated proof of work, and they send updates into the Bitcoin blockchain to help secure the state of their chain.
That would not shock me at all. Let's look. Okay, I gotta wait for Satoshi to finish. I got KMD.
Yeah.
All right, let's see what we get. KMD, yeah, that looks like an off ledger something or other because it's the same looking nonsense, and it's just KMD. And like here, we can see the size was 40, and KMD appears there, meaning basically everything with these 10 characters here were stripped out. So yeah, that's quite likely. It would not shock me at all if that's what that is. All right, they're gonna take me over the hook in a minute if I don't finish up. So thank you everyone. I'm around. Give me a yell if you have any questions, and yeah, have fun, play with this stuff.